अब मैं फिज़िक्स के चैप्टर 4 मोशन इन अ प्लेन की ऑब्जेक्टिव्स और समरी पढ़ूंगी। इन दिस चैप्टर you will be learning about the scalars and vectors, multiplication of vectors by real numbers, addition and subtraction of vectors by graphical method, resolution of vectors, vector addition analytical method, motion in a plane with constant acceleration, relative velocity in 2 dimensions, projectile motion, and last topic is uniform circular motion. Now I will read summary of the chapter. Scalar quantities are quantities with magnitude only. Examples are distance, speed, mass and temperature. Vector quantities are quantities with magnitude and directions both. Examples are displacement, velocity and acceleration. They obey special rules of vector algebra. A vector A multiplied by a real number gamma is also a vector whose magnitude is gamma times the magnitude of the vector A and whose direction is the same or opposite depending upon whether gamma is positive or negative. Two vectors A and B may be added graphically using head to tail method or parallelogram method. Vector addition is commutative. A plus B is equal to B plus A. It also obeys the associative rule. A plus B bracket 1 plus C A plus bracket के अंदर B plus C. A null or zero vector is a vector with zero magnitude. Since the magnitude is zero, we don't have to specify its direction. It has the properties A plus 0 is equal to A, gamma 0 is equal to 0, 0 A is equal to 0. The subtraction of vector B from A is defined as the sum of A and minus B. A minus B is equal to A plus bracket में minus B. A vector A can be resolved into component along two given vectors A and B lying in the same plane. A is equal to gamma A plus mu B, where gamma and mu are real numbers. A unit vector associated with the vector A has magnitude 1 and is along the vector A. N cap is equal to A upon A magnitude. The unit vector I cap, j cap, k cap are vectors of unit magnitude and point in the direction of the x, y and z axis respectively in a right-handed coordinate system. A vector A can be expressed as A is equal to Ax I cap plus Ay j cap, where Ax and Ay are its components along x and y axis. If vector A makes an angle theta with the z x-axis, then Ax is equal to A cos theta, Ay is equal to A sin theta and A is equal to A magnitude, that is equal to under root Ax ka square plus Ay ka square. Tan theta is equal to Ay upon Ax. Vectors can be conveniently added using analytical method. If sum of the two vectors A and B that lie in xy plane is R, then R is equal to Rx I cap plus Ry j cap, where Rx is equal to Ax plus Bx and Ry is equal to Ay plus By. The position vector of an object in xy plane is given by R is equal to x I cap plus y j cap, and the displacement from position R to position R dash is given by delta R is equal to R dash minus R, where x dash minus x I cap plus y dash minus y is equal to y j cap is equal to delta x I cap plus delta y j cap. If an object undergoes a displacement delta r in time delta t, its average velocity is given by v is equal to delta r upon delta t. The velocity of an object at time t is the limiting value of the average velocity. As delta t tends to 0, v is equal to limit delta r upon delta t is equal to dr upon dt. It can be written in unit vector notation as v is equal to vx I cap plus vy j cap plus vz k cap, where vx is equal to dx upon dt, vy is equal to dy upon dt, vz is equal to z upon dt. When position of an object is plotted on a coordinate system, v is always tangent to the curve representing the path of the object. If the velocity of an object changes from v to v dash in time delta t, then its average acceleration is given by a bar is equal to v minus v dash upon delta t is equal to delta v upon delta t. The acceleration a at any time t is the limiting value of a bar as delta t is tending to 0. A is equal to when delta time is 0, very limit, very small change in time is equal to delta v upon delta t is equal to dv upon dt, small dv upon dt. In component form, we have a is equal to axi cap plus ayj cap plus az k cap, where ax is equal to dvx upon dt, ay is equal to dvy upon dt, and az is equal to dvz upon dt. If an object is moving in a plane with constant acceleration, a is equal to a magnitude of a is equal to under root ax square plus ay square, and its position vector at time t is equal to 0 is r naught. Then at any other time t, it will be at a point given by r is equal to r naught plus v naught t plus half at square, and its velocity is given by v is equal to v naught plus at, where v naught is the velocity at time t is equal to 0. In component form, x is equal to x naught plus v oxt plus half axt square, where y is equal to v naught plus v oyt plus half ayt square, vx is equal to vox plus axt, vy is equal to voy plus ayt. Motion in a plane can be treated as superposition of two separate simultaneous one-dimensional motions along two perpendicular directions. An object that is in flight after being projected is called a projectile. If an object is projected with initial velocity v naught making an angle theta naught with x-axis, and if we assume its initial position to coincide with the origin of the coordinate system, then the position and velocity of the projectile at time t are given by x is equal to v naught cos theta naught t, y is equal to v naught sin theta naught t minus half gt square, vx is equal to vox is equal to v naught cos theta naught, vy is equal to v naught sin theta naught minus gt. The path of a projectile is parabolic and is given by y is equal to tan theta naught x minus gx square upon 2 v naught cos naught theta. The maximum height that a projectile attains is given by hm, maximum height of projectile is equal to v naught sin theta naught upon 2g, v naught sin theta naught ka square upon 2g. The time taken to reach this height is tm is equal to v naught sin theta naught upon g. The horizontal distance travelled by a projectile from its initial position to the position it passes y is equal to 0 during its fall is called the range r of the projectile. It is given by r is equal to v naught square upon g sin 2 theta naught. When an object follows a circular path at constant speed, the motion of the object is called uniform circular motion. The magnitude of its acceleration is given by ac is equal to v square upon r. The direction of ac is always towards the center of the circle. The angular speed omega is the rate of change of angular distance. It is related to velocity v by giving v is equal to omega r. The acceleration is ac is equal to omega square r. If t is the time period of revolution of the object in circular motion and v is its frequency, nu is the frequency, we have omega is equal to 2 pi nu, v is equal to 2 pi nu r, and ac is equal to 2 pi ka square nu square r. In this table, some physical quantities are given: position vector, displacement, velocity, instantaneous velocity, average velocity, acceleration, average, instantaneous, projectile motion, then circular motion, angular speed, centripetal acceleration. Learn the dimensions, unit, remarks, and symbols. Then read the points to ponder and do all the exercises.